So today we're going to be, again, reviewing 11.2 and 11.3, and then we're going to kind of look at the whole chapter 10 and 11, everything for exam 4, especially the toughest part, which is telling them apart, right? So we'll take a look at that. Due today you have 11.1 due today. On Thursday you have 11.2 due. And then next Tuesday you'll have 11.3 due, because your final will be next Thursday, the 25th. Yours is going to be, okay, so it's scheduled for 5:30, but you all decided you want to do it 4, correct? So then you can get out here. It'll be easier, make more sense. And then I'll be having review sessions next. So we do not have class next Tuesday, but I will do a review session 4 to 5. And again, you folks might be 4 to 5:15. And then the other class was 2 to 3:45. So these will be the same review session. This will just be a little bit quicker, and maybe with a couple less things, maybe. Exam 4 again is rolled into the final, so they're both in that same exam. So it means that 25% of that exam is going to be exam 4, and then of the rest of the exam, the final, 10% of that will be exam 4 material as well. So 35% of that exam is going to be chapters 10 and 11. And then the rest of the exam, about 20% from exam 1, 20% from exam 2, and about 25% from exam 3, approximately, within a percent or two. Okay, so that's how that breakdown is. I did this because people got a little mixed up on claims. This kind of helps you sort out from the words in the problem which one is the claim. So again, reminder, H naught is always, always, always equals. So things equals is things like equal, same, no difference. Those are all equals words. Also, independent, because remember, portions are the same, that's independent. So independent, and it's also all the no's. No relationship, no relation. Oh, and as expected, that's also equals, right? But the no's, no relation, no correlation, no line, no difference, those are all H naught claims. If your claim is the flip of that, then it's H1, like equal, not equal. That'd be the H1. Independent, dependent. That would be your H1 for that. No relation, related, the same, not the same, as expected, not as expected, no correlation, correlated, no line, is a line, no difference, it is different or differs. Right? So those are all the H1 phrases. If you encounter them, that should let you know that the claim is going to be H1. Now, your H naughts, just kind of the generic ones that you can use for chapter 10, no correlation or no line. Again, also, obviously, you folks can always use rho is equal to 0. And then H1 would be that they are correlated, it is a line, rho is not equal to 0. For the chi-squared, proportions are as expected is sort of the general one, so that's O sub I equals E sub I. And then H1 would be proportions are not as expected, or O sub I, and then it's O subscript I, right, is equal to E subscript I, where I represents each category, right? So O sub 1, subscript 1 would be the first category, O sub 2 would be the second category, O sub 3 would be the third category. And then ANOVA is H naught is, but the names are the same. So again, that would look like mu1 equals mu2 equals mu3 equals mu4, however many mu's you have. And then H1 would be at least one differs. Those would be the ones that you should use in your test. But the wording should be, the words you might run into will be, that you should be looking for, that will most likely be on the exam, would be things like correlation. So typically on the exam, I will likely do the ones for chapter 10, it'll likely be H1 is the claim. There is a correlation, right? I'm looking for the fact that there is a line. Typically for chapter 11, my claim is going to be H naught, especially on the exam. So you're going to get something like the proportions are as expected, or they're independent, right? Or they match what's expected. And then for ANOVA, the means are the same. So those are going to be the phrases you're going to see on the exam. And again, the ones that are circled in red are how I'm going to have on the exam. On the exam, your chapter 10 is going to be support. It's going to be claim is going to be H1. For chapter 11, on the 3 chapter 11 problems, the claim is going to be H naught. Typically we try to find that there is a correlation, or the proportions are what we expect them to be, or the means are the same. Those are typically what our goal usually is. All right, so next, about the final, these are the 3 things that you're allowed to have. Again, it's comprehensive, it's cumulative, it covers chapters 1 through 11. You're allowed 1-page notes both sides, so you can either use your 4 half sheets of paper from each of the previous exams, or the 3 from the previous ones and an extra one for this one, or you can start off brand new with a whole blank sheet and use both sides. But it has to be handwritten by you. You can use a combination, like 2 half sheets and one-sided of the new stuff, or whatever, right? So you can do whatever you like, as long as it adds up to that amount. And then any tables you want, the magic formula sheet, and obviously you definitely need a TI calculator. And I'll be borrowing ones from the library. They're going to be 84s, I think, so that way you have the GOF test in there. All right, so study guide for the final. These are all the problems you need. Make sure that you have a picture of this. This is your study guide. All of those previous problems from the past study guides. There are some at the back of the room, especially 1 and 2 are over there. I think I only have 1 extra of study guide 3 left over there. And then study guide 4, and study guide 4. So if you don't have a copy of those, I do have some extra copies of that. I think I should pull those out. But yes, those are the pieces you're going to need. And again, these are the other review sessions. There's also one at 5:30 on Monday if you want to attend that one instead. Those will all be the same. They're going to cover exams 3 and 4. This is the tutor schedule for the rest of this week. I had forgotten when I made this that really this is the last week of tutoring. They don't let the tutors tutor next week because they should be studying for their own finals next week. So these 2 days are basically done. There's nothing you can do about those. But these 2 days, these are all my tutors who had me. So feel free to ask them for any help. What day, Jason, what time are you folks in there, you and Connor?
2 o'clock.
2 o'clock. Oh, so you're here Tuesday, Thursdays at 2 o'clock? So you have Sarah on Thursdays. And Professor McHale, who are both great.
Both days.
Both days, yeah.
Uncle Samuel on Tuesday.
Yeah. Sarah, in particular, she's especially good because this is her 3rd semester tutoring here. She had me not last fall, but the fall before that. So she has a lot of experience. Plus, her goal was to be a math teacher. So she's really good at teaching, obviously, because she wants to be a teacher. So I do especially recommend her. She is our most experienced tutor we have. But at any rate, if any questions, if you want to work on your homeworks, over the weekend, I put zeros in for all the undone homeworks that people hadn't done yet, from all the previous chapters. So if you had not done all of your homeworks, you'll see a big drop in your homework grade. I have reopened those because to prepare for the finals, since the final is cumulative, you can do old stuff to prepare for it. So if you did not do homework from chapter 3 or chapter 4, chapter 2, you can do them now for full credit until next Thursday at 3:59. So get on those and get those done. Labs you can redo for half credit if you didn't do those, or if you have done them and not gotten full credit on them before, you can redo those for full credit. Just in the notes, in the comments, let me know that you're redoing it for more points so that I know that there was a previous submission I should look at. And I can give you full credit instead of giving you, partial credit because you're not late, if that makes any sense. So just, let me know so I know to look for that. All right, good. So chapter 11, point 2, that is using contingency tables. There's two types of tests, independence and homogeneity proportions, which are the same tests, because if we look back, contingency tables are where you have two variables, and those variables are both categories. So that means, for example, the one we had before was, back in chapter 4, we had the puppies, the rescues. We had black labs, chocolate labs, yellow labs. So type of lab, puppy, and then we had male and female, the gender of the puppy. So we knew two things about them. They're both categories. So we had that kind of matrix of numbers, of frequencies. That is a contingency table. When we have labels along the side and along the top. The test for independence will be phrases like no relationship or independent, or it could be the proportions are the same. I will also let you generically just use, the homework won't let you use this, but on the exams you can use this, O subscript I equals E subscript I. Again, I changes, it basically means all the different categories, right? O sub 1, O subscript 2, O subscript 3 for the different categories. And then H1 would be the opposite of that. There is a relationship, they're dependent, proportions differ, or O sub I is not equal to E sub I. This is the you calculate the chi-squared. Every observed value minus the expected value squared divided by the expected. You do that for every category, and then you add them up. I'm not going to make you calculate that. You can just use the calculator function for this. But I do expect you to calculate the expected values for the first one in the matrix, and the last one in the matrix. This is the formula for that. The row sum times the column sum divided by the grand total. You have to show me what you multiplied, divided, in there in order to get full credit. And you should label them. The first one in the matrix is E expected value of 1, 1, right? Because it's the first row and the first column, for example. And remember, it goes row then column. And I brought in my RC Colocan. Remember, it goes row then column. That's how I remember it. So RC Cola was my kind of my Q, row, comma, column. And you can see it exploded. It's okay, it's fine. It's lighter that way. It's better in many ways. Okay. And then to find the test stat, you use a chi-squared test, and you're going to put your observed values into matrix A. Remember, you put nothing into matrix B. The calculator will take matrix A, it will compute all the expected values, and it will overwrite what's ever in matrix B, and it will change the matrix size to fit, and it'll put your expected values into matrix B. It does that. You do nothing. Right? So you put nothing into matrix B, it will do that for you. You're just telling it where to store the expected values. Right? So it'll grab your matrix A, it'll compute them, and it'll store it into matrix B. It'll also give you the chi-squared value and the p-value. All right. I already did that. All right. So here are your steps. All right. H has there's no relationship between blank and blank. Or again, you could just put O sub I equals E subscript I. And then H1 would be that blank and blank are dependent or are related. And again, you can always put O sub I is not equal to E sub I. And then write down your alpha. Use a chi-squared test to find your chi-squared or your p-value. And then also find your first and last expected values. And then steps 4 and 5 are the same. So I will give you folks just another minute or two to finish up quiz problem number 1. And then we'll go over that. All right. So all 5 steps. So the first step is H naught Right, type of crime is independent of known and criminal, or like I said before, you can just put down O sub I equals E sub I. And then H1 would be O sub I is not equal to E sub I. In other words, it's related, type of crime is related to known and criminal. Step 2, the alpha is 0.05. Step 3, you need to calculate the first and last expected values. So here's my matrix. And I strongly recommend drawing square brackets around your matrix so that you have a better handle on what to input into your calculator. You don't get confused or mixed up by that. It also makes it really clear how many rows and columns you have. So the first one is going to be this spot here. So you're going to find the row total, 1158, the column total, 51, and divide by the grand total, 1945. Here it is, and that's the first row, first column, so it's E1, comma 1. And you get 30.4. 3 sig figs. Yeah, 3 sig figs is good. And the next one is this last one, so that's this one here, which is the last row and last column. So there's 2 rows, so it's the second row. There's 3 columns, it's the third column, so it's E2, comma 3. And you're going to grab the row total and the column total, divide by the grand total. So that's where you get your answer there of 570.1. Or 570 would be fine as well. I think 3 sig figs. And then you're going to put all of your observed values into matrix A. And then you're going to do stat test, chi-squared test of A, and put little brackets around the A so I know it's a matrix. So you don't have to write the stat test, but I would like you to please write chi-squared test of what? Of A, so I know that you understand that you're using a matrix and not using lists or something weird and crazy like that. And then give me your chi-squared, which is, help me out.
112, 0.37.
0.4, good, fair enough. And your p-value, which is?
3.9663 e negative 25.
Right. So you might have seen, especially for you at home, you might have seen p-value of 3.96 and stopped there. That's 396%. That should set off flags, right? You can't have that kind of percentage for a probability. So anytime your p-value is larger than 1, you darn well better have an e negative at the end. And in this case, you have e negative 25. So here's the deal. If your e is e negative 7 or less, then you can totally write down 7 zeros and then the number. If it's more than 7, e negative more than 7, you can just write down e negative and that number, because I don't expect you to write down 25 zeros. That's ridiculous. So this is good. For some of you, I had some students who ended up, their calculators gave them 0. So that's fine, you just would write down 0. But in that case, you definitely need to make sure you definitely have to have your chi-squared, because that's how I know whether you got the correct number or not, because there's lots of ways of getting 0. All right, so make sure you have your chi-squared there, so you get full credit for this problem. And then, so then I'm going to compare my p-value to alpha. My p-value is what?
That
Less than or greater than alpha?
less than.
Less than, so am I going to reject or not reject H naught?
Reject.
If we're going to reject H naught, so then do I have enough to claim or not enough evidence?
More than enough evidence.
Yes, more than enough evidence to reject the claim, because our claim was independent. So my claim was H naught, independent of known and criminal. Good. Homogeneity of proportions. So this one is where you're saying the proportions are equal. So then your H naught would be that P1 equals P2 equals P3, however many proportions you have. And then H1 be at least one proportion differs. I don't think you're going to have those on. I don't think you're going to have those on the exam or on the test or on the homework, but just so you're complete in your knowledge, this is where we're looking at many different proportions, or populations, sorry, and we want to see if the proportion of them is the same. So this was the problem we did last class for that, right? This is what we did last class. Right, this was to see if the proportions are the same for these different groups, and we found that they weren't. But I'm going to have you do these ones. So here are proportions for these different groups. So first of all, how do we know what kind of problem this is? What kind of problem is this?
Okay, this looks like the homogamy of this constant.
What do we think? Take 30 seconds with your neighbors. What kind of problem is it? Think about it.
It's a testing for
Okay, so do we have categories across the top?
Yes.
Okay, categories there. Do we have categories along the side or not?
yes.
Is endangered and threatened, are these two different categories?
Yes.
Yeah, so the question is, are they endangered or not? That, so that's that question and answer. Does everyone follow? So two different categories of the same question. So we have categories across the top and along the side. That's two variables that are both categories. That is when we have the matrix. So that's how we know it's a chi-squared matrix problem. That is our clue. Someone mentioned something about relationship or independence or something like that, right? So then that also leads to a chi-squared matrix problem. All right, so go ahead and I will give you folks 5 minutes to do this. Seem reasonable? Okay, so don't forget to find your first and last expected value. Also, when you input this into your matrix A, it's a different size than your previous matrix, right? But if you just change those two numbers at the very top, it'll change the type of matrix, the size of matrix you have, to the one that you want, and then you can just overwrite the values that are in there. I'll show you what I mean. So if you go to, how do you get there? You go to second and then down to matrix, down here. Don't ignore the names, don't mess with the names at all. Go over to edit, and you want A, hit enter there, and just change it to the size you want. If I'll write 3 by 3, I'll put a 3 in here. Bam, it becomes 3 rows, hit a 3 there, and bam, it becomes 3 columns. And just overwrite any values that are there already. Okay, so again, that's second, and then the fourth one down, that is matrix, to get to the matrix. If you mess up and mess with the names here, then you can reset. Otherwise, you're going to have trouble. So make sure that you just go to the edit and use it from there. And again, if you didn't have the totals yet, those are the totals there for you. You're going to need those. Especially to find your expected values, you're going to need those. Here's your grand total right there. Okay, so I feel like people are done. Okay, let's go over it. So step 1, H naught is O sub I equals E sub I. That you folks had?
Yeah.
And H1, O subscript I is not equal to E subscript I. Which one's your claim? H naught? Oh, they want to say if there is a relationship, so that's probably H1.
Yeah, H1.
Relationship would be H1, so then is that your claim? So H naught's all the no's, no relationship. Claim, so you're going to use the word support later on. Step 2, alpha is 1/5. Step 3. So for step 3, you're going to throw your first and last expected values. So your first one's E.
E11.
Yep, it's the first spot. So E1, first row, first column, 1, 1. And you end up getting 247 times 81 divided by the grand total of 369, which is what?
54.2.
54.2, thank you. And then let's see, this last one here is the last row. So it's row 2, column 5. So E2, comma 5. So that's that row total 122 times the column total 137 divided by the grand total 369. And you got
45.3.
45.3. I'm going to write down the exponential places just so just because it's weird, this one is the same as the chi-squared, and now people get confused by the fact that they're the same if you round. So I'm going to make it 2, 9, so you can see that they are actually different. And then you did chi-squared tests of matrix A, and you got a chi-squared of 45.31, and a p-value of was it 0.545? No, 0 what?
It was 3.42, the E negative 9.
Ah, thank you. I don't remember that one. 3.42 E negative 9. It's definitely small. So then step 4, you said your p-value is less than alpha, so we rejected H naught. Which means that we have enough evidence to support our claim of relationship between, or you can say, or I might just, honestly, I'd probably just say that blank and blank are related, between type of amphibian amp and endangerment. Endangerment, or whatever, right? Claim of blank, and just put in something that makes sense. Whatever you kind of, want to copy that. Okay. Good, good. Right. Relationship between class and endangerment, that's what they said. Okay. So here it is a little bit prettier, maybe. Optionally. There's other options. And then the last thing we covered was analysis of variance, 11.3. So again, this is when, if we only have 2 means, then we would just do a 2-sample t-test. If we have 3 or more means, we do ANOVA, analysis of variance, to compare 3 or more means. And H naught is that all the means are equal. So mu1 equals mu2 equals mu3, however many mu's you have. And if there's no difference in the means, then the between group variance would be about the same as the within group variance. Which means that I have groups. If here's my first group, here's their variance, second group, their variance, third group, that's their variance. Between the groups, if they all have the same mean, then their between group variance should be the same as well. Since we're comparing variances, it's called ANOVA, analysis of variance, and I'll give you an example of what we're talking about. What we're doing is we're taking the between group variance over the within group variance. So here is the example I used last class, only with numbers in them. So there are first graders. They have a mean of 42 inches, and their variance is kind of between here and here. We have fourth graders. They vary about this much over here. And then we have seniors, which vary about this much. So the within group variance is all about the same, about this much. But between the groups, they have a really big variance between the groups, right? From seniors to kindergartners, or first graders. So their between the group variance is much bigger than their within the group variance. So that's how we know that they don't have the same mean. What we do is we look at that ratio. If they were the same, then this F statistic would be close to 1. When it's close to 1, then we can say, okay, the means are probably the same. But when the between group variance is much bigger than the within group variance, that's when we say that the means are not the same, and we reject the null hypothesis. So on the exam, I think it's important for you to understand that that's the ratio of the variance between the groups compared to the variance within the group. So on the exam, I'm going to give you the between group variance. I might call it variance between samples, or the between group variance, and the within group variance, or the variance within the sample, something along those lines, right? Group or sample. but it'll be within and between. Find the F statistic, you just take the between group variance and divide by the within group variance. I will also give you other things to confuse you, right? Like X bars and S's and N's and things like that, right? And alphas, just to kind of throw you off. But you should recognize that it's just those two things divided by each other. All right, these are the steps. All right, state your hypotheses. H naught mu1 equals mu2 equals however many mu's you have. Step H1, at least one differs. Find your alpha. Compute your p-value. How do you do that? Put your first list into list 1, your second group into list 2, third group into list 3, and so forth. And then you're going to do ANOVA, stat test ANOVA, and you're going to list out all your lists. L1, comma, L2, comma, L3, comma, L4 if you have 4 lists. You know how to find the L1, right? Just second one. The comma is above the 7. So you got to look for that. If you look right above the 7, that's where your comma is. And that'll give you your p-value and your F statistics. So write both of those down. And then steps 4 and 5 are the same. All right, so I'll give you folks just one more minute if you need to finish quiz problem 2. And then we'll go over it. If you've already finished quiz problem 2, start your break now and come back at 5:12. Sorry, 5:10. 6:10. 5:10. Come back at 5:10. Just make sure you write down your F statistic and your p-value on your paper so I can check those.